Hi guys, this is Laminate Theory Part 2. I will explain from thin plate kinematics to summary. Here I have a quiz for you. What is the correct description about the stress on the loaded multi-layer laminate plate when each layer has different stiffness each other? Number 1. The stress in each layer is different each other. Number 2. The stress in each layer is the same. Let's review the previous video shortly. We looked into the equation of forces. The forces per unit length acting on the xz and yz sections perpendicular to the neutral plane can be calculated by integrating the stresses over the thickness. As in the same way as the previous slide, the moments per unit length acting on the yz and the xz sections perpendicular to the neutral plane can be calculated by integrating the stress multiplied by a moment arm z over thickness. Based upon the resultant force and moment equations for one composite plate, we can derive the equations for multi-layer laminate composite plate shown here. The example case here is composed of 6 layers. The forces and the moments for the entire plate can be calculated by summing up all the forces and the moments for all the layers in the corresponding direction. Superscript K is not the power, but the sequence number of corresponding ply. Substituting the strain terms of stress of force and the moment equation of a multilayer equation, we can get the force and the moment equations in terms of strains and the curvatures. The strains and the curvatures of the neutral plane have nothing related to the variable z in the thin plate theory. Therefore, we can take out the strains and the curvatures of the neutral plane out of the integral. Then we can get the final expression for forces and the moments. Introducing the normal stiffness matrix A here, coupling stiffness matrix B here, and the bending matrix D here, we can simplify the matrix equation as shown in the next slide. Here we have the familiar equations you can see in the many books related to the composite materials. A matrix with a green color is the extensional stiffness matrix related to x and y plane deformation. T matrix with the blue color is the bending stiffness matrix related to the perpendicular deformation to xy plane. B matrices with the red color are the coupling stiffness matrices between tension and bending deformations. This picture shows 6-layer laminate. Let's assume the variation of strain epsilon x is linear through thickness, and all the other strains are ignored. Then, the strain variation is linear in the thickness direction, and the variation of stiffness Q is discontinuous because each layer has its own stiffness. Therefore, stress variation is discontinuous at the interface between layers. The answer to the quiz is number 1. The stress in each layer is different each other. Here we have a summary. The forces and the moments for the entire plate can be calculated by summing up all the forces and the moments for all the layers in the corresponding direction. stiffness matrix is composed of the normal stiffness matrix A, coupling stiffness matrix B, and bending stiffness matrix D. Strain variation is linear in the thickness direction. Variation of stiffness Q and the stress distribution are discontinuous. If you watch the previous videos, you can easily understand upcoming videos. In the previous video, E0034, I explained the price tier due to out-of-plane deformation of coated belt at angle. Recently, I started to explain the laminate theory. The next video will be price tier part 8, which is the laminate theory part 3. I will explain the stiffness matrix elements and their characteristics. Please hit the like and catch the brand new videos by free subscription. So what are you waiting for? See you at the next video. Goodbye guys.